Okay, 5.2 properties of functions, number 1. I'm going to try to show you as much as I can, as much information as I think will be helpful for you when solving these type of problems. And hopefully it'll help you work smarter and not have to work harder when solving these. So this first question wants to know, is the following function even, odd, or neither? So symmetry, just a few notes. You're going to be given some equation or some function f of x. If it's equal to f of negative x, which means you just change the x value from positive to negative or vice versa, and they're equal, then this is called even. Or we say it has y-axis symmetry. It's going to say y-axis. Okay. With ordered pairs, you can put points on the graph and you can say, if you have some ordered pair x, y, and all you do is change the sign of x and leave the y value the same, if this point is on the graph and that point is on the graph, then we say it's even. So this is another way of looking at it with ordered pairs. All right, then we can compare f of x to negative f of x. So this is something that you saw in the note section or the overview. If this is the case, you take your original function and you multiply the whole thing by negative, and if those two are the same, then we say it has x-axis symmetry. There's no special name for x-axis symmetry. With ordered pairs, what that means is we would change the sign of the y value this time. So you have some ordered pair x, y, and then if you change the y value only and it matches, then we say it has x-axis symmetry. So here's one scenario. Here's a second scenario, and then there's one more. We compare f of negative x to negative f of x. And what this means is you're going to change both the x and the y. And if that is on the graph, then we say it is odd, or we say origin symmetry. Origin symmetry. Now, this also needs interpretation, so I'm going to show you how to work this out. Okay, and I'm going to show you how to look at the equations and be able to tell. So, starting with number 1, we have some function m of x is equal to x plus 2 in parentheses squared, and then we have a plus 2 outside. So this plus 2 and this plus 2, these are shifting and moving the graph. Okay, so if you look at this, this is a x squared. Okay, so normally, okay, a parabola would be just a regular x squared, would be right here in the middle. Y equals x squared. All right, this has y-axis symmetry, or it's even if you just flip it straight across. However, with the transformation or the shift of the graph, something else has happened. So this plus 2 will move it left 2 units, 1, 2, and then that plus 2 will move it up to 1, 2. So you would have a parabola that got shifted and is now doing this. Okay, this red parabola is no longer even if you flip it across the y-axis. And there's nothing below the x-axis to say that there's a mirror image across. And there's nothing down here in the other quadrant. So we would lean toward even, but visually you can see that once we move it from the center, so if that x moves left or right, it is no longer right in the dead center of that y-axis. So this is not going to be either even or odd. Okay, it would be even. It would lean itself toward even because of the 2, but once you see it visually, it's neither. But let me show you how to work it out using all these symbols. So we're going to be taking, this is my original f of x, or sorry, this guy right here is my original f of x, or my m of x. I'm going to start here. I'm going to change it to negative x. Now I need to simplify so you can see, because when I replace it, it won't look the same. So I'm going to square this, and I'm going to do a shortcut. X plus 2, this is what I'm doing. I'm doing x plus 2 times x plus 2, and I'm just doing it all mentally, and I'm going to write that down and simplify this so you can see a different version. So this is equal to x squared, and then plus 4x, and then plus 4. So that's what you get with this, and then you got this plus 2 out here. And then at the end of the day, m of x is equal to x squared plus 4x plus 6. Okay, so this is what that's equal to when we simplify it. And you really need to understand and be able to see it as a simplified, because when we change this, it won't look the same because you got to simplify it to realize that. So now we're going to do m of negative x. And what that means, I'm going to replace the x in here with the negative x. Negative x plus 2 squared plus 2. Okay. Right now, if you compare this to this, they look different because of the negative x. However, when we go to simplify it, you'll see that they match up. So what I'm going to do is I'm going to actually show the whole work this time. So I'm going to do negative x plus 2 times a negative x plus 2. And then I have my plus 2 at the back. Running out of space. Okay. So when you FOIL this, you got to do negative x times negative x. It's going to give you a positive x squared. And usually that's the case. Whenever you have a negative raised to an even power, that negative times a negative is going to give you a positive. Even if it was a 4, 6, 8, any even number, whenever you plug in a negative, it's going to go back to positive. So the sign won't change from what it originally was. So negative times a negative gives you negative x squared. Negative x times 2 will give me a minus 2x. And then 2 times a negative x will give me another minus 2x. And then 2 times 2 will give me a positive 4. And then plus 2, bring that down. So when I simplify this, I have x squared, and then I have a minus 4x, and then plus 6. So now, see the difference. Okay, the x squared part is the same, the 6 is the same, but in the middle, one was positive 4x and one was negative 4x. So when we compare these two, m of negative x, this is not the same as this. And even so, once you simplify it like this, instead of me having to go through all that work, I could have just done it from this point here, okay? So just to show you again, m of negative x, that would be a negative x being squared plus 4 times a negative x, and then plus 6. It doesn't have an x. So when you square a negative, it becomes positive. And then 4 times a negative is going to give you a negative 4x. And then you bring down your plus 6. So see, that's exactly the same that we got when we FOIL it out. So I would recommend that you simplify your equation first, and then you try to manipulate it using these. Now, normally I would check them all, and we can. It just takes a little bit more effort. I'm going to go ahead and do that last step, the negative. So what I'm doing now is doing the negative f of x. So all you really need is 3 things. You need f of x, the original one. Sorry, you can't see that. F of x, the original one. You need f of negative x, which is what we just did. M of negative x, since I have m. And then we have to put the negative on the outside. Okay. So if I do the negative on the outside, that would be equal to just multiplying everything over here by negative, or everything right here by negative. So that would become a negative x squared. I guess let me kind of box these off. This guy is the negative, and then multiply this by negative, so it'll be minus 4x, and then minus 6. So just distribute that negative throughout. So here are the 3 forms. This is what you need. You need your f of x, or whatever letter they use. You need your f of negative x, or m of negative x, and then the negative on the outside. And to check symmetry, we check this one to this one. You can see they're not the same because of the negative 4, so it's not even. Then we check this one to this one to see if they're the same. And they're not, because that's negative. This is positive, that's negative. These are the same, but these are different. So everything has to be the same sign, so it's not odd. And then you check this one to this one, the top one to the bottom one. You just check all 3. And so that's what that's what these symbols mean. Okay, you replace the x with the negative, you replace the outside with negative. You're going to get 2 new functions, and you just compare them all together. That's what these are saying. See if they are equal. See if they are equal. I'm going to show this a couple more times just to kind of help you help drive that point home, because it is a lot to learn at once. But once you practice it and do it a few times, it'll begin to clear itself up. But the more you know about it, the better this will go, the easier I think it'll be for you. But the symbols and everything sometimes can be a little bit confusing, so I want to try to make sure I explain it all very well. So I'm doing it a couple more times. So anyway, this one is neither even or odd.